All right, so this is your lesson on the rock cycle. So, first off, we're going to talk a little bit about some vocabulary and then we'll dig into what we're talking about today. So, a rock is a relatively hard and naturally occurring mineral material. So, that means it's going to have to be a solid object. It's not going to be liquid. It's not going to be fluffy. It's not going to be anything that we would want to use as like soft. Okay. All right, it's going to come out of the ground. It's going to be naturally occurring. That means people didn't make it, that it was something that occurs naturally on its own. And it is a mineral material, and that just means it's made out of minerals. All right. And there are three main types of rock: sedimentary, metamorphic, and igneous. All right. The next thing we need to talk about is sediments. Sediments are small pieces of rock. So if you think about sand or like really small pebbles, things like that, or sometimes even cases, small pieces of shell, those are sediments. Okay. Weathering is any process that breaks down rock. And there are two types of weathering. There can be chemical weathering and mechanical weathering. Chemical weathering is caused by decomposition or a chemical reaction. So it is chemically changing what that rock is. It's decomposing, it's falling apart, coming apart, it's decomposing, or it's having a chemical reaction. It is reacting with something. It could be acid, it could be another mineral that's around it. It could even be some kind of salt water or something that's in the liquid that it's in. Mechanical weathering is caused by any physical force that is breaking down the rock. So if something hits the rock, if it smashes it, if it slides against something else and it kind of scrapes on it, that would be mechanical weathering because it's breaking down the rock. Erosion is when natural forces move sediments away from an area. So if we think about rain washing sand away, so if you've ever been on like a dirt road or a driveway or seen where rain has washed a gap or a rivulet down into that sand, that is erosion. So erosion is when those sediments are being moved from one area to another. And that can happen with wind and water. So it's not just when it rains or something like that. Deposition is natural forces that add sediments to an area. So when that rain washes away some of the dirt off of the dirt road, it's got to go somewhere. And wherever it ends up, that's what we call deposition. So it can be eroded in one area and deposited to another place. All right. Now we're going to talk about the types of rock. The first type of rock we're going to talk about is sedimentary. This one's fairly self-explanatory. It is made of sediment, so it's made up of pieces of other rock. So in this rock over here on the right-hand side, you can see little pieces of other rock that are kind of stuck together. And in this one, you can see where layers of sand stacked on top of each other or layers of sediments stacked on top of each other to make those lines in that rock. Okay? And we've already said sediments are made by weathering and erosion. That's those rocks being broken down. Then they're going to be deposited somewhere and they begin to cement. So they're going to begin to stick together. All right. And this video example you can come back to and look at later. It's like the jelly beans that are all stuck together. That would be our sedimentary rock. The next kind of rock we're going to talk about is metamorphic. These are made of other rocks that have melted some, just a little bit, and been pressed together. So this is heat and pressure that creates this kind of rock. So if you can see, this could have been a sedimentary rock to start. Whoops. But now it has been melted some and kind of squashed together. So you can see where those layers have been melted just a little bit and squashed in together. So it's kind of like playing with Play-Doh. You kind of twist it and squash it in together, and you've got a bunch of other like stuff melted and mixed in there with it. And the same in this case. This just happens to have bigger chunks that were melted together and squashed in. Okay. All right, now the last one is igneous rock. Igneous rock is made of rock that has been completely melted and cooled. So if we think about magma, when magma hardens, when it cools down and hardens, it turns into an igneous rock. Now, there's two types of igneous rock, and this is based on where they cool, where they're found. So intrusive igneous rock cools and hardens below Earth's surface, so it cools down a lot slower. And extrusive igneous rock cools and hardens above Earth's surface, so it's going to cool down a lot faster. Okay, so intrusive is inside, extrusive has exited Earth, and it's cooling outside. All right, so igneous rock is generally going to be uniform in color and structure. So this rock over here, it's kind of a reddish brown, and it's got a bunch of bubble holes all in it. Okay, so it looks pretty much the same no matter which area you look at it from. You might be able to tell you're looking at it from a different side, but it's the same color and has the same kind of structure. And the same thing over here with this rock. Okay, it's almost like glass. This rock is what we call obsidian. Some people call it like, oh gosh, I forgot the other name for it. Anyways, we'll talk more about different kinds of examples of these rocks. But this is obsidian. This is almost feels like glass. It's really, really smooth and it'll break really easily. So if I were to take a hammer and hit that, it would shatter into a bunch of different pieces. Okay. All right. So now let's watch our video that kind of explains and shows us the rock cycle, shows us what it looks like. Okay. I've already got it loaded right here, so I will play that for you.
I bet you thought rocks are just rocks, right? Nope. There are three major types of rocks: sedimentary, igneous, and metamorphic. But the coolest thing about rocks is that each one has the ability to change into the other kind.
How is that possible? Sedimentary, metamorphic, and igneous rocks change into each other in a process we call the rock cycle. No, not that kind of rock. This kind of rock. Yeah, that's more like it. The first type of rock we'll talk about is sedimentary. On the surface of the earth, wind and water break down rock into tiny pieces. Those pieces might collect in a riverbed, on a floodplain, be swept into sand dunes, or collect on the ground. Over time, layers of these rock fragments build up and start to weigh down on one another. Eventually, they get fused together to form sedimentary rocks. The cool thing is that if you look closely, you can still see pieces of the original rocks or sediment that were bound together.
Let's do a demo. For our rocks, we're going to use jelly beans. Each flavor of jelly bean represents a rock or mineral that has been broken down by wind and water through a process called erosion. We put our jelly beans in this bowl and add some honey and cornstarch. They're the bonding agents to hold our pieces together, kind of like glue for rocks. A little time and pressure has turned our jelly bean pieces of sediment into a brand new rock.
So what happens if you apply both heat and pressure? It becomes a metamorphic rock. Metamorphic rock may form by friction of the Earth's shifting crust, pressure deep within the Earth, or even radioactive decay. The heat and pressure cause the rock structure to change, so it takes on a new form. Even though it's changed, you can often still see structures of its original components.
Let's take our sedimentary jelly bean rock and turn it into a metamorphic one with heat and pressure. To add pressure, we'll put this heavy pot on top. For heat, we'll stick it in the oven for about 30 minutes. After it's cooled, you can see how our jelly bean rock has formed a more solid unit. However, you can still see the individual pieces of candy, but the structure has fundamentally changed.
The third type of rock in the rock cycle is igneous. When rocks get superheated deep within the earth, they melt and form a liquid called magma. If magma rises to the surface or moves up in the earth's crust, it begins to cool. Igneous rocks have a uniform structure throughout, but will have different properties depending on whether they cooled on the Earth's surface or within the crust.
To turn our jelly bean metamorphic rock into an igneous rock, we're going to melt it in this pot of boiling water. When our rock has cooled, you can see how all the different pieces combine to make an igneous rock with uniform structure throughout. Pretty cool, huh?
But this is only part of the story. We showed you one path through the rock cycle, but really any rock can go from one type to another. For example, igneous rocks can turn into either metamorphic or sedimentary. And metamorphic rocks don't have to become igneous rocks. They can be broken down again and become sedimentary. Or the sedimentary rocks can get pushed deep within the earth to form igneous. See, all of the rock types are connected, making a cycle that never ends. The end.
We are the rock of the world. We are rocking so much until the
All right. All right, so they gave you an example with jelly beans. So when we were talking about the examples on here, so the sedimentary rock is those jelly beans that were stuck together. So they took a little bit of some honey and cornstarch and made them stick to each other. So that would be our sedimentary jelly bean rock. The metamorphic rock is the jelly beans that they put in the oven, and they put that big pot on top of them. So they warmed up, they melted a little bit, and they had that pressure pushing on them and kind of squashed them together. So you could still see individual pieces, kind of like you can see the different colors in the stripes or streaks here in this rock, and you can kind of see the different colors in the rocks here. So those jelly beans were kind of squashed together and kind of melted in, okay? All right, and then the igneous rock is the one that they completely melted. So they melted it in that pot of hot water and let it cool, and it looked almost exactly like this rock right here when it was done. It was kind of like jelly almost, okay? So those are our 3 rock types, and that was how that rock cycle kind of fits together. And now I am going to draw a rock cycle for you. So I'm going to help you understand just a little bit more and make sure we are all on the same page about what that looks like, okay? So first thing I'm going to tell you is I have color-coded this again. Hopefully that's going to help you a little bit. So we're going to start with sedimentary rock. Now, we've already said that to create a sedimentary rock, we're going to have that rock broken down into pieces, and then they're going to have to stick together, okay? So to get to a sedimentary rock, it doesn't matter where you start, but those processes are the same. So just like the video example they showed you, all these rocks can go every single way. So to get to a sedimentary rock, and I'm going to color code this, so it's all yellow if it's going to that sedimentary rock. And it doesn't matter which rock type we come from. If it's pointed to that sedimentary rock, it's going to be the same kind of process. So it's got to be that weathering and erosion, it's got to be deposited somewhere, and it's got to start to stick together. So I'm going to add that to our rock cycle. I'm going to Okay, so it's that weathering, erosion, deposition, and cementation. So it's got to be broken down. That's what that weathering and erosion is. It's got to be deposited somewhere, so it's got to be left somewhere, and then it's going to start to stick together. So that's the cementation, okay? And I'm going to add it to this other yellow arrow over here, just so we don't confuse ourselves. Okay. All right, now, the same thing with metamorphic. It doesn't matter what kind of rock we start with, but to get to a metamorphic rock, it's the same process. So these orange arrows, those are for that metamorphic because it's written in orange. Those orange arrows are going to be the same process no matter where we start. Okay, so for a metamorphic rock, it's a little bit more simple. So it's just going to be heat and pressure. So they're going to be stuck together. They're going to be squashed a little bit and heated. Okay. All right. Now, igneous rock is a little bit different. Now, this in the middle. The magma is not a rock type. We're just using that as a step on the way to an igneous rock. So to get to magma from any of the rock types, to get to that point, we've got to melt. So if I'm coming from a sedimentary rock, if I melt it, it's going to be magma. If I come from a metamorphic rock and I melt it, it's going to turn into magma. Okay? Right, so if we melt a rock, it turns into magma. It doesn't matter what kind it is. And the same thing happens to igneous rock. So igneous rock can be melted and turned back into magma as well. Okay? All right, now, to get to an igneous rock, you've got to start with melting. So it's got to melt first. That's what the igneous rock is. It's got to be completely melted, and then it's got to cool down. Okay? So it's got to melt, and then it's got to cool down. All right. So these are our 3 rock types. This is how they are connected, and we do call it a rock cycle because it doesn't matter which way you go around here. It doesn't matter which direction you're heading. You can get from one rock type to another, okay? So now, please remember magma is not a rock type. You only have metamorphic rock, igneous rock, and sedimentary rock. Magma is just a step on the way to creating an igneous rock, okay? And that's it.